Hi guys, how are you? Welcome to my YouTube channel, Field of Science. Today we are learning about Physics Class 11 chapter, Work Energy Power. We may expect 1 to 2 questions from this chapter. Chalo, हम start करेंगे without wasting any time. What is work? Work means force into displacement. If take an example, this object is moved from here to here by an applying force in this direction. Then what is work done from moving here to here? Then resolve this force into two components. One is F sine theta and this is F cos theta. And what is work done? Work done is equal to F into S. Then F into S means force here is F cos theta. Then displacement is S. So work done is equal to Fs cos theta. If theta equals 0, then it is called as positive work. So work done is equal to F into S. Second, if theta equals 180 degree, then negative work, this is called as negative work, W is equal to minus F into S. If theta equals 90 degree, then it is called as 0 work done is equal to 0. Let's solve on some applications. First application is if mass m is lifted from ground to height h from here, then what is work done on bringing this mass from here to here? Work done is equal to Fs cos theta. What is force here? Force is equal to mg, mass into acceleration, so mg. Then s means height h. So F into S cos theta means work done is equal to minus mgh on bringing here to here. Minus is due to it is acting along opposite to the gravitational field. See here, it is lifting upward means opposite to the gravitational field. So this negative sign. Next we move on to second application. If the mass is placed in lift and the lift is moving upward, accelerating upward to the height h, then what is work done? Work done is equal to minus m into g plus a h. G plus a means acting upward acceleration with the gravitational field g. This is came from the rule law of motion, from the chapter law of motion. Minus m into g plus a into h. Minus is due to moving upward. If it is moving downward, then g minus a, because acceleration is downward and the gravitational field acting also downward, so g minus a. Here there is no negative sign because negative sign is due to it is moving upward direction opposite to gravitational field. Here it is moving downward direction, it is does not opposite to gravitational field, it is towards the gravitational field, so it is not the negative sign. Next we move on to third application. If the pendulum is oscillated from here to here, then what is the work done? Work done is equal to, according to this, the length of the pendulum is L and it is lifting to this position means the height is h. And what is this? This is L minus h. Then this is mg, force. Work done is equal to force means minus mg L into 1 minus cos theta. There is some derivation we don't need, we only need this formula, remember it. Then fourth, if the rod is lifted from ground to here, if the rod is moved from ground to here, the rod length is L by 2 and making angle theta with through h, height h. Then work done is W is equal to minus mg L by 2 sin theta. Minus is due to opposite to the gravitational field. Remember the formula. Fifth application. If the man lift a bucket from a water with height L having thread of mass m, then what is the work done? Work done is equal to minus capital MGL. Means capital MGL means this work done. Work done from this is capital MG, force into displacement is L, and plus small m, mass of the thread. Mass from how much it is lifting? L by 2 length, because it is center of mass, if we have the mass, so L by 2, then mg into L by 2. So sum of this will give the work done of this system. Then we move on to sixth application. If you have to lift the chain from here to here, we have to pull here. So what is the work done from lifting here to here? Then minus mg L by 4. Okay, next seventh. If chain of having n rings is lifted from here to here, Then what is the work done? Work done is equal to force. What is force? Force acting is minus mg by n. Mg by n. And what is distance traveled? L by 2n. See here, L by 2n. This is the distance traveled, then L by 2n. This is whole length, L by n. Here half means L by 2n. So minus mg by n into L by 2n is equal to minus mgl by 2n square. Next, move on to conservative force and non-conservative force. What is conservative force? If the force in the work done is 0, then it is called conservative force. Why the work done is 0? Because it is independent of path traveled. It does not depend on a path which is traveling. See here, system A is from a boy is traveling from A to B. See here, this is one way, this is second way, this is third way. But this both work done is equal because does not depend on the path traveled, what he traveled. Okay, for example, gravitational force, electrostatic force, and spring force. Let's see come to non-conservative force. Non-conservative force means if the force acting, the work done is not equal to 0. Means it depends on the path traveled, so the work done is not equal to 0. See here, W1 not equal to W2 not equal to 3 because this is different path, this is different path, this is different path. It depends on a different path, so the work done is not equal to 0. For example, frictional force. See, it may depends on the smoothness and the roughness of the plane. Next, note point. Area under Fs graph gives work done. Remember this point, this is very important. Area under force into displacement graph gives work done. Next, we move on to energy concept. Energy is measured in joule or ergs or electron volts. 1 joule is equal to 10 to the power 7 ergs. 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. These values are very important, remember it. There are two types of energies, potential energy and the kinetic energy. Let's move on to potential energy. Potential energy is possessed by virtue of its motion, which is possessed by virtue of its position. Means the ball is placing here, means it has potential energy. This with respect to position, so it is called as potential energy. U is equal to mgh. Relation between force and potential energy. What is the relation between force and potential energy? They may ask some question from this concept also. What is the relation between force and the potential energy? Force is equal to minus dv by dr. See here, force is equal to minus dv by dr. Differentiation of potential energy gives the force with negative gradient. Remember this, with negative gradient. Case first, stable equilibrium. Stable equilibrium means if you consider a bowl, if you place a ball here, ball anywhere from here in the bowl, it will come place here. It will always come to here. So that is called stable equilibrium. Here potential energy is equal to minimum potential energy. Here differentiation of potential energy du by dx equals 0 and d square u by dx square is equal to positive because always comes to here. So it is positive. D square u by dx square is equal to positive. Then case 2, unstable equilibrium means if consider this bowl in place it in upright, then place the ball here, then release. It always falls here or here or here. It does not stand stable. So it is known as unstable equilibrium. Here u potential energy is equal to maximum potential energy. Here du by dx is equal to 0 and d square u by dx square is equal to negative because it does not in stable equilibrium. It is falls anywhere. So it is negative. Then case third, neutral equilibrium. What is neutral equilibrium? The body is moving with uniform speed. It does not have any motions. See here, it is stable. Neutral equilibrium. This is known as neutral equilibrium. It is stable here. So it is called neutral equilibrium. There is no variations. U equals 0, du by dx equals 0, d square u by dx square equals 0. Here 0 because of this is in uniform. Next we move on to kinetic energy concept. Kinetic energy is possessed by virtue of its motion. Here kinetic energy is equal to 1 by 2 mv square. This is means it is possessed by virtue of its motion. Means if the bullet is traveling from here to here, if the bullet is traveling, bullet is fired from gun, then it has kinetic energy, does not has potential energy because it is does not in stable, but it is in motion, so it has kinetic energy. Kinetic energy is equal to 1 by 2 mv square. Next we move on to work energy theorem. What the work energy theorem says? Work done is equal to change in final kinetic energy minus change in initial kinetic energy. Please remember this. Work done is equal to change in final kinetic energy minus change in initial kinetic energy. Means W is equal to 1 by 2 mv square minus 1 by 2 mv square. Majority problems are asked from this formula only, from this chapter. Application 1. We can understand by this application. See here, this is spring. It has 0 extension, x1 equals 0. After expanding it by applying some force F, it expands x distance. X distance means x2 is equal to x extension. Then work done is, first we have to find first final kinetic energy. What is final kinetic energy? Spring formula is 1 by 2 kx square. See here, 1 by 2 kx2 square minus what is first initial kinetic energy change in 1 by 2 kx1 square. See here, 1 by 2 kx square. x2 is what? X. So x square minus half into k into x1 is 0. See 0. 0 square. Then work done is equal to 1 by 2 kx square. This is how we can solve the more than application from this concept. Next we move on to power concept. What is power? Rate of doing work is called power. What is power? Rate of doing work is called power. Power is equal to W by T. This is formula. Power is equal to work done by time taken. Remember this formula, work done by time taken. See here, another formula also there for power. How it is derived? Power is equal to F into S cos theta by T. F into S cos theta means work done. So F into S cos theta by T. This S by T is known as velocity. So Fe cos theta. So Fv, power is equal to Fv is another formula. Power is measured in watt or horsepower. See here, 1 horsepower is equal to 746 watt. Let me solve from applications of power. First, if the bucket is lifted from height h by the person, what is the power? Power is equal to work done by time taken. What is the work done from lifting this bucket from here to here, height h, mgh. So work done is equal to mg, power is equal to work done by time, so mgh by time. Then second application, if n bullets are fired from the gun, then what is the power? Power is equal to work done to for n bullets is fired, n 1 by 2 mv square. 1 by 2 mv square is the bullet traveling, means kinetic energy. So what done is v 1 by 2 mv square by t, but n bullets, so n into 1 by 2 mv square by t. Then third application, if water lifted from height h and it is ejected from pipe with velocity v, then what is? Then first power is equal to work done by time. Work done means there is two work done. One is mgh. This is lifting the water from height h, and plus another work done is 1 by 2 mv square. Ejecting means it has some velocity, so kinetic energy is versus also 1 by 2 mv square whole divided by t. Then this relation is asked many more times in the NEET exams. Remember it. Fourth is average power is equal to instantaneous power by 2. This is some derivation we don't need. We don't only need the formula. Average power is equal to instantaneous power by 2. Then fifth application, if gravel falls on a conveyor belt which moves with velocity v, what is the power? Here force is equal to v dm by dt. Am I right? Force is equal to v dm by dt. Power formula, another formula for is F into v. Means v, here force is v dm by dt, so v square dm by dt. This is very important formula. These questions are asked in NEET exams. Sixth application is when water ejecting from pipe, what is the power? See here, the ejecting pipe v dm by dt with the velocity v dm by dt, so dm by dt is equal to av rho. If velocity increases by n times, dm by dt is equal to area into velocity into density of water. If velocity increases by n times, then what happens? Then dm by dt whole dash is equal to n times the dm by dt. And what is the force after increasing? F dash is equal to n square initial F. And what is the power after increasing? P dash is equal to n cube P. Then seventh application, how to find efficiency? Efficiency is equal to power output by power input. Remember it, power output by power input. Next, we move on to very important concept of this chapter, collision. Collision means two bodies bombarding each other in a collision. There are types of collisions. One is one-dimensional collision and second is oblique collision. One-dimensional collision means after if two bodies are collide each other, after collision, it moves in a same direction, same straight line. Then it is called 1D motion, 1D collision. And oblique collision means if after collision it moves in a different directions. See here, after collision it moves in a different direction. It is known as oblique collision. There are types of collisions. First one is elastic collision, second one is semi-inelastic collision, and third one is inelastic or plastic collision. First we move on to elastic collision. Elastic collision is due to law of conservation of momentum. If collision obeys law of conservation of momentum and law of conservation of kinetic energy, then it is called as elastic collision. See, what is law of conservation of momentum? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is before collision, this is after collision. Then law of conservation of kinetic energy says 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square is equal to 1 by 2 m1 v1 square plus 1 by 2 m2 u2 square. So the collision which obeys these both rules is known as elastic collision. What is semi-inelastic collision? The collision which obeys only law of conservation of momentum but not the law of conservation of kinetic energy. Then this collision is called semi-inelastic collision. Then third, inelastic or plastic collision. Here collision only obeys law of conservation of momentum but not the law of conservation of kinetic energy. Here, if two bodies mass m1 and m2 collide each other, after colliding, they are moves in the same velocity. They are attached to each other and they moves in the same velocity v. Before they are u1 and u2, but after this it has only one velocity v. So m1 u1 plus m2 u2 for this, and after colliding each other, m1 plus m2 into v. In elastic collision, if we have to find velocity of individual object after collision, there are two formulas. First, we have to find the v1 means is equal to 1 m1 minus m2 into u1 by m1 plus m2 plus 2 into m2 u2 by m1 plus m2. Then v2 we have to find means v2 is equal to 2 m1 u1 by m1 plus m2 plus m2 minus m1 into u2 by m1 plus m2. This formula behind there is a derivation. We don't need that. We only need these formulas. Then we move on to application from this collision. First, fraction of kinetic energy returned gained by mass m. If they ask the question with fraction of kinetic returned by the mass m, then we have to use this formula. K1 by k is equal to m1 minus m2 by m1 plus m2 into whole square. If the second, fraction of kinetic energy transferred from m1 to m2, how much kinetic energy transferred from m1 to m2 they ask means we have to use the formula k2 by k1 is k is equal to 4 m1 m2 by m1 plus m2 whole square. In question they will give the k, okay, don't worry. Then what is coefficient of restitution? Coefficient of restitution means E equals relative velocity of separation, means relative velocity of separation by relative velocity of approach, means after collision they separate each other, by before collision they attract each other. Then so v2 minus v1 by u1 minus u2. For elastic collision E is equal to 1. For plastic collision E is equal to 0. For other collisions E equals 0 to 1. Just remember this, which is very important. Then we move on to note point. If ball is left from here, it falls to ground and bounce back from to height h1. It left from height h0. After bouncing it reaches h1. What is the velocity after bouncing? V means v, this is u initial, this is final. V equals minus e into u. Remember this formula, this is very important. And how much height it is bounced? h1 equals to e square into h0, initial height h0. h1 is equal to e square into h0. If n number of bounces are there, then vn is equal to e power n into u. Remember it, vn is equal to e power n into u. Then hn equals to hn equals to e power 2n into h0. Remember it, hn is equal to e power 2n into h0. Then total distance covered is S is equal to h naught into 1 plus e square by 1 minus e square. Then total displacement covered is S is equal to h naught. Displacement means final position and initial position, so h is equal to h naught, how much covered. Then time taken, total time taken, t is equal to root of 2 h naught by g 1 plus e by 1 minus e. Average speed is equal to root of g h naught by 2 1 plus e square by 1 plus e whole square. Then average velocity is equal to root of g h naught by 2 1 minus e by 1 plus e. You have to remember this formula, somewhat complicated, but you have to remember. There are behind derivations, these are not required. Then we move on to semi-inelastic collision. In semi-inelastic collision, if you have to find the velocity of individual object after collision, then v1 is equal to m1 minus e into m2 by m1 plus m2 into u1 plus m2 into 1 plus e by m1 plus m2 into u2. v2 is equal to m1 into 1 plus e into u1 by m1 plus m2 plus m2 minus e m1 by m1 plus m2 whole u2. Then if you want to find the loss of energy when it is after collision, then kinetic energy is equal to 1 by 2 m1 m2 by m1 plus m2 into 1 minus e square into u1 minus u2 whole square. If it is in opposite direction, this minus. Next come to plastic collision. In plastic collision, if you have to find the velocity is equal to after collision velocity is equal to m1 u1 plus m2 u2 by m1 plus m2. Then loss in kinetic energy is equal to 1 by 2 m1 m2 by m1 plus m2 into u1 minus u2 whole square. If in opposite direction, this minus is changed to plus. Then move on to 2D collision. If two-dimensional collision means after collision, these balls masses are moving different directions. Here different direction v1 v2. Then along x direction, what is m1 u1 is equal to m1 v1 cos alpha plus m2 v2 cos beta, remember it. And along y direction means here along y direction m1 v1 sin alpha is equal to m2 v2 sin beta. Majority these formulas are asked, please remember it. So I hope you have understand what I taught today. If you have any doubt on this concept, just you comment in YouTube or you can message me in Instagram or Facebook. If you want my short notes, please subscribe this channel and just follow and message me on Instagram at filmistar789 or Facebook Rohitar, and message me, we will help you there. Thank you for watching. Don't forget to subscribe and like.
Bye guys, have a nice day.